Hi there! This lesson is on more exponent properties, namely power of a power, power of a product, and power of a quotient. Our objective is to use the definition of exponents and the exponent properties of multiplication and division to build an understanding of how the power of a product, power of a power, and power of a quotient properties work. First, let's review. A to the fourth is the same as A times A times A times A. It's repeated multiplication. And A to the 1 is simply A. We should also know that if I have two like bases, A, and I multiply them together, to simplify that, we're going to add our exponents. So it would become A to the quantity m plus n. And with division, if I have two like bases that are being divided, A and A, we'll subtract these exponents. And remember, in subtraction, the order matters. So A, m minus n, or the top exponent minus the bottom exponent. So that's our review. Now let's see how this kind of helps us build these other properties. Power to a power. If we use the definition of exponents, it's like saying w to the fourth squared, or in other words, w to the fourth times w to the fourth. Well, now this just becomes two like bases that are being multiplied together, which we just reviewed. We would say w to the 4 plus 4, or w to the 8th. So if there's a property about this, we would want to look at these values in our exponents, 4 and 2. How do 4 and 2 relate to 8? Well, 4 times 2 equals 8. Let's hold on to that and see if that continues as a pattern. Okay, so here's another example. H squared cubed. So by definition of exponents, this is the same or similar as h squared times h squared times h squared. I have h squared 3 times being multiplied. Again, if we come back to our properties of multiplication, it says to add the exponents if I have a like base. So h, 2 plus 2 plus 2. Or in other words, h to the 6th. So remember the previous problem, we looked at the values 2, 4, and 8 and how those related. We said 2 times 4 equaled 8. Does that still work with 2, 3, and 6? Well, it sure does. 2 times 3 equals 6. So it looks like we might be onto something here. And in fact, when you have power to a power, you will be multiplying the exponents. So a to the m raised to the n is the same as saying a to the m times n power. Here's another property that relates to multiplication, the power of a product. So again, we're going to expand this out using the definition of exponents. So I'm going to have negative 2 CD times negative 2 CD times negative 2 CD times negative 2 CD. 4 times because the power is to the fourth. Now I'm going to look for all my same bases and combine them. So here I see I have negative 2 times negative 2 times negative 2 times negative 2. In other words, negative 2 to the 4th power. We want to keep that in parentheses because it's the negative 2 that's being multiplied repeatedly. I'm going to go to the next base. The next one I see on line is C. I have C times C times C times C. Or, if I write with exponents, C to the 4th power. And then I'm going to finish with D. I also notice I have D times D times D times D. Again, the definition of exponents would say I could write that as D to the 4th. So right here, if we stop here, we can see very clearly that when we had this original expression, negative 2CD, all raised to the 4th, we merely put each base inside there, each to the 4th power. I wonder if that works all the time. Let's finish this one real fast though, because I have this term here, negative 2 to the 4th. We can simplify that. Negative 2 to the 4th power. Negative 2 times negative 2 is positive 4. Times negative 2 is negative 8. And times negative 2 is positive 16. So 16, C to the 4th, D to the 4th. And if you're not good with the negative 2's and doing those on your own, you do have a calculator you can use to verify and check things as well. Now, remember, don't forget this interesting fact here. It seems like we're just putting the exponent on each base. Let's try another one. Power of a product. Okay. Again, I'm going to use those definitions of exponents to expand this out. So a squared times b. Again, a squared times b, and a squared times b. So I have a squared b 3 times. Go for all your bases and combine them together. Well, here I see I have a squared, and a squared all being multiplied together. So in other words, I have like this if I was to rewrite all my a's next to each other. Again, this comes back to that property of multiplication. Just add your exponent. So this is going to simplify to a to the 6th. Now I'm going to go for all my b's. Well, I see I have b times b times b. I could write those all out together too. Well, that's b cubed. Well, this doesn't seem to match the last one we did. Right? On the last example, we suggested, well, maybe I just put it on each term. That works here for the b, but how does that 2 and that 3 get us to the 6 on the a again? Remember that power over power rule? A squared to the 3rd gives us the a6. So we could say that we share this exponent, still maintaining our power rules. The a squared gets the 3, and the b gets the 3rd power. That's where the a6 b cubed come from. Let's see if we can apply those rules here. So I'll write this all out, 3f squared a to the 4th. Alright, so there I've written it out 4 times to represent the 4th power. Go through and gather all my like bases. I've got 3, 3, 3, and 3. That's 3 to the 4th. I have f squared, f squared, f squared, and f squared. So that's f squared to the 4th. A is a to the fourth. Don't be frightened. Remember, look at each base individually. Don't look at the whole problem. Each base by itself. 3 to the fourth. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. You can also use your calculator. 3, the little arrow caret button, 4. So this is 81. If I focus here on the f squared to the fourth, we were just looking at the power of a power. We know that we multiply those numbers. So 2 times 4 is 8. So f to the 8th power. And then our last base is a to the fourth. So that's a 4. That's the answer we get when we use the definition of exponents. And you can always expand this out. And you can expand it out further if you want, writing each one of these as 3f, f, a, and then just counting all your bases. But let's see if we can apply that power of a product rule here. So power of a product says share the exponent with each base. So we're going to have 3 to the fourth, f squared to the fourth, and a to the fourth. And then simplify. 3 to the fourth, 81, f squared to the fourth, multiply those exponents, f8, and then a4. Same result. They both work. Again, power of a product property. When taking the power of a product, share the exponent with each base. I'm cautious to say distribute the exponent, even though it may look and feel a lot like distributing. I'm going to just use that term sharing because distributing is a whole other process that works with polynomials and multiplication. So here's a challenge problem. Remember, don't be overwhelmed. Look at it one piece at a time. So if we focus on this first piece here, 3x cubed y0 squared, the first thing I notice is y0. Anything to the 0 power is 1. So this reduces just to 1, and we don't need to write that. So now this becomes 3x cubed squared. Share that exponent with each base. So 3 squared, x cubed squared. Simplify it. 3 squared is 9. X cubed squared is x to the 6. 3 times 2 is 6. So now let's switch over to this other part. Well, x1 is just x. So this is like saying x, y to the third. Power of a product, share that exponent with each base. X cubed, y cubed. So now I'm going to bring that down and write it down next to my other piece that's been simplified. So now we've made it here like bases, x6 and x cubed. Those are being multiplied together, so we're going to add their exponents. So 9x, 6 plus 3 is 9. And then the y is the only y base, so he stays the same. Break it down into smaller pieces. Focus on one base at a time. And the last property we're going to look at is power of a quotient. This is going to resemble a lot of what we've already done. First, let's expand it out using the definition of exponents. So I have x cubed over y to the fourth times x cubed over y to the fourth times x cubed over y to the fourth. So I just wrote it out. Now combine your like bases. think of this as one long fraction line. So x cubed times x cubed times x cubed, well, that's x to the 3 plus 3 plus 3, or in other words, x to the 9. Then look at your bottom, your denominator. Y to the 4 times y to the 4 times y to the 4, that's y 4 plus 4 plus 4, or y to the 12th. There's no negative exponents, so everyone stays where they originally were. X in the numerator, y in the denominator. So let's kind of look at this and see the patterns if we can find any. I started off with x to the 3rd cubed and got x to the 9. So I have 3, 3, and 9. Well, 3 times 3 gives me a 9. But what about the bottom, the denominator? There I have a 4 and a 3. 4 is the exponent on the y, 3 is the outer exponent. But I ended up with a 12. Well, it still works. 4 times 3 equals 12. So I wonder if this is the pattern here. Here's another guy. He's a little trickier. There's lots of moving parts, and we have this negative here. Okay. Let's write him out. Negative 7a cubed over b to the 5th times negative 7a cubed over b to the 5th. One base at a time. I see negative 7 times negative 7. Negative times negative gives me positive. 7 times 7 is 49. A cubed times a cubed is a to the 6th. That's all my numerator. Go to my denominator. B to the 5th times b to the 5th. That's b to the 5 plus 5, which is b to the 10. There are no negative exponents, so everyone's staying where they are. A still on top and b still on the bottom. So in the previous problem, we looked at patterns. Negative 7 and a squared, how does that relate to 49? Well, negative 7 squared is 49. Look at our A base. I have a 3 and 2, but I ended with a 6. We know 3 times 2 equals 6. So it still seems to be holding. What about the B's? B starts with a 5, raised to the power of 2, and we're ending with 10. Interesting. It still works. 5 times 2 equals 10. So let's see this guy in action. If I take this one, notice the first thing different here is that negative exponent on the outside. Previously, we've talked about negative exponents meaning to flip it. And then we're going to switch it to a positive. Because this is the whole quotient being negative, we're going to flip the entire thing. Denominator becomes the numerator, numerator becomes the denominator. So now I have n squared over w cubed. That takes care of the negative all to the 3rd power. So expanding that out, n squared, n squared, n squared over w cubed, w cubed, w cubed. So we simplify this using our multiplication properties. So n squared times n squared times n squared is n6. And w cubed times w cubed times w cubed is w9. But does that still work? Because if I multiply these, like we said earlier, 3 times negative 3, that gives me negative 9. My w exponent is positive 9. But notice the w switched. It went from the top to the bottom. So that's where that negative 9 comes from. N is squared, so 2 raised to the negative 3. Well, that's negative 6. But n has a positive 6 on it. Remember, it flipped sides. It's on the top. Anytime it flips from the bottom to the top, or the top to the bottom, we have that negative. So power over quotient is the same thing. We're going to share the exponent. Whether it's positive or negative, it does not matter. We share that exponent. Let's look at this in the manner of sharing. First thing I'm going to do is look at the inside stuff and simplify and reduce all of that. So m to the first is simply m. H to the 0 simplifies to 1, so we don't need that anymore. And k to the negative 4, we're going to take this and move it on the top, so k, and now he has a positive 4 exponent. So that's the inside of those parentheses, all raised to the negative 3rd exponent. So the quotient property said, share it. But this isn't a quotient. Now this is a product. This is power of a product. But it still says to share them. So this is going to share to the m. So m to the negative 3. And it's going to share with the k. So k to the 4 times negative 3. M to the negative 3 means I have m to the 3rd in the denominator. We went from top to bottom to the bottom. K to the 4 times negative 3 is k to the negative 12. Again, a negative exponent says take him and move him to the other side. So k to the positive 12 moves to the bottom. There's nobody left, so we're going to put our placeholder 1 up there. Alright, I want you to take a moment, hit pause, and try those practice problems on your page. When you're done, come back, hit play, and I'll show you the answers and kind of walk you through it. It won't be a full explanation, but I will walk through how to do them. Okay, so you've tried them. Let's talk through these some. First, I'm going to simplify what's on the inside of this. So 2, w moves to the bottom because he's negative, and v squared stays up top. And that's all to the 4th power. So I share that 4th power, 2 to the 4th, v squared to the 4th, that's v to the 2 times 4. So v8 over w shared with a 4. And then 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 v8 over w4. Okay, here's another one. One piece at a time. I'm going to start at the beginning. R squared to the 5th. This is 2 times 5. So R to the 10. Move over here to the next section. Well, this is y squared v all to the 3rd. So y squared to the 3rd is y6, and then v to the 3rd. So y6 v cubed. Never get distracted by the complex look of any of the problems. One piece at a time. Let's work on this piece here. So this 5 goes with the 2, 2 to the 5th. K And then it's 4 times 5, 20. And then this other piece stays k to the third. 2 to the fifth is 32. Then k20 times k to the third. Add those because we're multiplying the bases now. So k to the 23. Okay, here we go. Just share the exponent with everyone. Inside those parentheses, nothing can be simplified. So we're just going to share and multiply. J to the 5 times 4, J20, over K to the 3 times 4, K to the 12. G to the 2 times 4, G8. Now we've got this guy. Watch out for that negative. That negative is going to stay with the 4. So when I share this exponent, I'm going to write the work as negative 4 to the 5th y7 to the 5th, go over x cubed to the 5th. Go through and simplify. When you type this in your calculator, you need to keep those parentheses around the negative 4. Negative 4, all raised to the 5th, is negative 1024. y7 to the 5th, that's 7 times 5, so y35, over x 3 times 5, x to the 15. Watch out, he's got a negative exponent. So I'm going to go through and flip my entire fraction inside first. So 2y to the 6 moves to the top. R squared C7 goes to the bottom. And it's all to the positive 5th now. We took care of the negative by flipping everything over. Now it's the same thing we've been doing. 2 to the 5th. y6 times 5, y30, over r squared times 5, which is r10, and c7 times 5, c35. Simplify. Anytime you have that base as a number with an exponent, simplify. 32, y30, all over R10, C, 35. So here's our summary. The power of a power, power of a product, and power of a quotient are merely extensions and combinations of the definition of exponents being repeated multiplication, as well as the multiplication and division properties. In other words, we continued to use that definition of exponent and apply our properties of multiplication and division of bases to derive and to find these patterns. Don't forget, when you're in doubt, you can expand it out. Okay? When in doubt, expand it out. However far you need to go, that's okay. And focus on one base at a time. And that's it for today's lesson.